Right. Imagine you had a PA to take care of your email and sort it out so that you only had to see the really important things. Or if you had some kind of smart filter you could put on your inbox and then throw away all the spam and crap and it actually worked. You just got to see the really important things and somebody else took care of all other just fluff that's in your inbox. Well, technology exists to do the same around managing your wells. But most people, quite simply, are not using it. If you look at the way people try and manage their wells, they use a service that brings in real-time data, and they draw lines on the screen, and they try and go well by well by well, and they try and do that every day. That's not smart, and that's not management by exception. The technology exists to do real-time analysis of all your wells, to do management by exception, so the software will tell you which are the important wells that you need to look at. And the techniques around machine learning, the techniques have applied since the 60s. Nothing has changed around machine learning. The only difference is that we have more computing power to actually do anything with it. The problem we have in our industry is we're not collecting the right information to actually be able to apply the machine learning. So it's all there, we can do it, but we're shooting ourselves in the foot every time. So what I'm going to show you today, briefly in the 15-minute chat, is some best practices around management by exception for your wells. So companies with better analytics capabilities are twice as likely to be at the top quartile, 5 times more likely to make decisions faster, 3 times more likely to execute decisions as planned. You cannot do that if you're just looking at your wells day to day as lines on a screen. You've got to change the way you do your business. So, would you like this? Automatic tracking of downtime, so you actually understand how much downtime you're really sustaining. Automatic identification of wells, where you can increase production. Processes so that you don't have to look at your wells each day. You only need to look at the ones with issues. The software can tell you. And then tracking and understanding of failure modes so that you can drive run life improvement. And lastly, your engineers need to be focused on solving problems, not trying to find them. So, monitoring. All of us can pick up this, right? Amps goes to 0, can't get it restarted. Frequency 0, pump's dead, call a rig, bring a new well. That's easy. So, if you're talking about monitoring, those of you that are operators, this is a series of statements that are a continuum, that are an improvement on how you do your business. So, within these colors, which color do you think your operating oil company currently operates in? What's that? Green? Okay, good. Right, where would you prefer to be? 12 is where we want to get to, right? We're going to need to use tools to do that. You can't keep doing things the same way as you've always done them. Right, this is really what we should be doing when we're doing monitoring. What this represents is the TDH that an ESP produces. 100% means all the stages are working, it's giving you the drawdown it's supposed to. If something happens in your pump, be it wear, be it deposition, scale in the pump running the wrong way, hole in the tubing, ultimately it looks as if the ESP is doing less TDH. We need a tool that identifies automatically for us when a well is doing less TDH and when it's changing with time. This is the same effect, but this is when it's occurred from the beginning, from when you first installed the well. This could be wrong rotation, it could be a missing coupling, it could be a broken shaft during startup, it could be a plugged intake during startup. You're never going to catch this from your trend plots looking at lines on a screen. You only catch this by using diagnostic tools to analyze the ESP performance. These tools exist. I'm not going to do a sales pitch, I'm not going to show you my software. I'm talking conceptually about what we have to do our business better, differently, and drive things forward. It's a big change in the industry, right? We're losing people like John Patterson. Symposium's never going to be the same again if he's not here. But what we need to do is evolve and help the younger guys follow through Right. Downtime. How often are our wells shutting down just because of daily events, power outage, facilities upset? All stuff that may be preventable if we know we have it and we understand how frequently it's happening and how much oil it's causing us to lose. So what's this actually look like? Up, down, up, down, up, down. We're not getting 100% uptime of our ESP. So how do we address that? How do we attack that? How do we get more value as an operator? How do we keep our wells producing longer? We need to understand our problem. We need to be measuring it. Most operators I talk to are still operating here, recording downtime manually each day. And if it's less than 6 or 12 hours, they probably don't even bother. So the tool exists within software to automatically track downtime every day. What happens on an ESP when it switches off? Current goes to zero, frequency goes to zero, volts goes to zero. We can track that time. The software can back calculate the missing production when it's switched off. So most people are operating here on a purple level around downtime, and they should be operating down here. Right, optimization opportunities. Optimization opportunity means your ESP is running. But are you running it at the right frequency? What's the IPR of your well? Can you get more production out of it? And let's say you've got 100 wells. Are all your wells running in an optimized condition? The software exists to automatically do the diagnosis every well, every time you have a production test, and then the software will automatically rank all those wells and tell you what all your candidates are, what you need to do to them, and how much incremental production you're going to get. So, this is our software doing analysis of an ESP. Equally well, it'll do analysis of gas lift. We have a gas lift module. Basically does a pressure versus depth curve, compares theoretical pump performance, which is this, to actual measured pump performance. That orange dot is your intake pressure measurement. Using the intake pressure measurement, we calculate an actual PWF. We plot that in an IPR curve, so your IPR curve is always known and accurate. And we show you where your operating point is relative to the pump curve. We also then predict ahead in 1 Hz intervals how much incremental production you get if you increase the speed of the pump. We identify whether the pump's in range, down thrust or up thrust. A lot of the stuff Attica talked about today in the presentation, this is available for everybody, not just the PDO. This is the ranking of your opportunities. Software spits all of that out. Software also has management by exception workflows, so that when your pumpers come in the morning, it tells you what's running, what's shut down, what's in an alarm condition, what's got a communication failure. All of these things need to be flagged, because that's the first thing you do in the morning when you come in to take care of your production. Then your engineers can start looking at these production enhancement opportunities. Case history for you. An operator in West Texas. Our software said, this is what the pump should be doing. It's doing nothing like it. It's basically 50% of the pump's not working. We recommended a proactive workover. They said, nah, it's just a well with it's poor inflow, it's not a good well. And I said, no, it's categorically a pump failure. You need to change out the pump. So they did it. This is what they found inside the pump stages. Severely eroded pumps, iron sulfide inside the pump stages, calcium carbonate in the pump stages. Prior to the change out, we were doing 265 barrels of oil a day. Afterwards, 875 barrels a day. Here's what happened to their production on the production curve. They told me about this case history 34 days after their workover. They'd made $1.4 million in incremental production just from that one well. So that operator is now using our software on 60 wells, and it's not one of Carlos's wells.